Hi there, folks. Okay, we're going to continue our video in the ANOVA in the F test, the ANOVA technique analysis of variance. We have had this answer in the previous video, and now we're going to um, answer the problem talking about the post hoc test. So you can recall that our step one is about the hypothesis testing, or rather the hypothesis of the problem. We have this. Our p-value is here. Our step three is here. So since our p-value is less than your alpha, hence we reject your null hypothesis. And step four is that we say that there's enough evidence to reject the claim and conclude that at least one mean is different from the others. The next question that comes to mind, what mean is that? Is it the mean in medication, exercise, diet that differs, okay, from others? So a post hoc test is deemed important in these kinds of scenario, wherein we need to really find out what is where is the difference coming from. So we're going to devise this, and we're going to make use of the post hoc test called the Tukey Kramer Q test, or in some just call it a Tukey Q test. So we have had this table here down below. We're going to make use of this in determining our Tukey Q test. Excel doesn't provide us with an automatic data analysis um, process to get the 2K value, but we can get it manually. So we'll start with the medication. We're going to first pair each grouping here. So we have medication versus exercise. We're going to have that medication versus exercise, medication versus diet, and exercise versus diet. So those are the all the possible combinations that we can have when we need to pair up each of the groups in order to determine the difference. So let's start with the difference here. So the word difference here refers to the absolute difference of the averages of each pair. So we're going to start with this. So let's click on equals. So we want to get the absolute. Let's type in ABS for absolute value of this one minus this one. So we start first with the medication versus exercise. So medication versus exercise on that, and then we click on equals. Absolute difference of we have medication versus diet, and then we will have the absolute difference of exercise minus diet there. Okay, so after that we're done with the difference. Next is we need to determine the n of of per group. So here n of group 1, group 2. Group 1 refers to the first words here. Group 2 means to the second words here. So for group 1 we have medication, here medication, here exercise. So the n of group 1, how many they are? So actually they're all 9, they're all 5 rather. So I think we don't need to take on that. 5, 5, 5. Okay, so there you go. There are some cases wherein the groups are not the same. Okay, so this video will show you if ever that will happen. Okay, so we need to get the SE, or the standard error. Okay, so I have and got here the formula for the standard error. Let me show you this, and here. So here's our formula for the 2K Kramer standard error. So the formula states that your SE is equal to the square root of twice your mean square within, okay, times 1 over n sub I plus 1 over n sub j. I and j. I is the first group, and j is the second group. Okay, so I think there's an error here in the formula. This should be 0.5 or 1/2. I think there is an error in this page. There's no change, but I know that the formula is 1/2, not 2. Okay, so we need to change this. Okay, there's an error. So it's going to be 1/2. Let me adjust this a bit so that we can still see. Okay, so that's it. We're going to follow that. So this is going to be equals the square root function because it's a square root function that we're going. It has a square root with it. So we have 1/2. Again, this is 1/2, not two. So 1/2 is 0.5, right? Times we use an asterisk. Mean square within. The mean square within is found over here. Click on that, and then we multiply again. Open parenthesis. 1 over the group for group 1 plus 1 over the n, the sample size for group 2. And we close the parentheses twice. And I want to type in F here. No, the dollar sign. Okay, in order for us to not change the mean square within. Okay, so I'll click space with that, or yeah, I'll click return rather. And then I want to copy this all the way down, and then it will give me the different types of SEs, though they're all the same because that's because your N are the same. So if ever your N is not the same, the values for the SE will not be the same. Take note of that. So it just so happened that our N are all the same. So how do we get the value for Tukey Q statistic? So that is going to be your difference divided by your standard error, which is the same for all cases. So we just click on return and then bring them all down here. So we can see that the Q statistic for the medication versus exercise is 6.05. The Q statistic for medication versus diet is 3.17. The Q value is in exercise versus diet is 2.87. And we want to consider this. We want to differentiate this and compare this with our critical value for the 2K. Okay, and I have here a calculator that gives us that. So this is the social science statistics website. The other website I forgot to tell, the real statistics. I don't know. This should be 1/2. This is the calculator for the 2KQ, and this will give us the values for the other critical values for alpha level 0.5 and 0.01, or 0.05 and 0.01. So what we want to do is to insert first the number of means or groups. So we have 3 groups: the medication, exercise, and diet. And we want to get the degrees of freedom within groups. Okay, so within groups, we can see the degrees of freedom here is 12. Okay, so the degrees of freedom is 12. So therefore, our n is the population is 15. 5 plus 5 plus 5. 15 minus 3 is going to give us 12. So which is, you can see it there, 12. And then we just click on calculate Q critical. So we can see that the critical value is 3.77. And it's clear to see that, remember our decision rule. Every time we compare a test statistic, for instance here, a Q statistic to the critical value. If ever the test statistic is greater than the critical value, meaning we're going to reject the null and tell that there is a significant difference there. So since our Q statistic, let's just put it here, our critical value CV is equal to 3.77. Therefore, if we're going to compare it with each of them, we can see that here in the medication versus exercise, we reject the null because the Q value 6.05 is greater than 3.77. So meaning we reject the null here, and therefore we say that there is a significant difference between medication and exercise. So there is a significant difference. Anyways, can we close this Google Chrome now? So we say that there is a significant difference. Significant difference between medication and exercise. And there is no for both medication versus diet and exercise versus diet because all their values are strictly less than the critical values. Therefore, we do not reject, we fail to reject the null, and telling us that we do not, there is no significant difference between medication and diet, and there is no significant difference between what? Between exercise and diet. Okay, so we can see that there's a significant difference only in this part here. So let's highlight that. Let's make use of orange. Okay, so therefore, we have answered the question from our ANOVA test here. The question again is that there is no difference among means. So we have proof that there is a significant difference. That is, um, there it should be at least one mean is different from the others. What mean is that? And we have shown using the post hoc test, the Tukey Kramer Q test, or the simply the Tukey Q test, that there is a significant difference between medication and exercise. Okay, that is to say that if we're going to compare medication versus exercise, there is a significant difference when it comes to the difference of the blood pressure. Meaning, if you're going to, it means that if you're going to choose between medication and exercise, medication is much more better than choosing exercise. Okay, that's the implication. Whereas, if we're going to compare medication and diet versus exercise and diet, there's no significant difference between them. That is to say, if we're going to compare, if either we're going to choose medication versus diet, you either choose between them because they somehow give the same results. And if you're going to choose between exercise versus diet, so you can either choose between them because there's no significant difference between them. But if you're going to choose between medication and exercise, it's better to choose medication than exercise because it gives you a pretty much significant values. It pretty much um, better, okay, difference in the blood pressure. Meaning it lowers the blood pressure. Okay, so that's the implication of the 2K Q test. That is one of the many post hoc tests after ANOVA. So we have a lot more. Actually, there are even like Shifei's test. We have the Duncan test, but the 2K Q test or the 2K Kramer is one which is stronger than the other. Okay, briefly speaking. Okay, stronger than the other post hoc tests. So hopefully this video helps in helping you determine the post hoc test using the 2K and using Excel as the instrument. Okay, so thank you very much for watching. Hope you would like and subscribe, and see you soon for more videos. Thank you.